The first thing last week, beginning of last week, or the end, maybe toward the end of last week, we talked about categories of acids, and they were based upon if they were a strong electrolyte or weak electrolyte. And so we listed out 6 acids that would be in the category of a strong acid. Let's see if you guys remember those. You have to memorize them. So we're going to go back. Don't look them up in your notes. See if you can remember them. Give me the 6 strong acids.
HCl.
HCl.
HI.
HI.
HBr.
HBr.
Sulfuric acid.
H2SO4. 2 more. HNO3. The last one you probably won't get is HClO4. When we deal with these strong acids, these break apart 100%, which means that they break apart perfectly into 1-to-1 ratios. So what I mean is if we take HCl and dissolve it, it breaks apart 100% into H plus ions and Cl minus ions. 100%.
Did you really look up what the 7th one was?
I never did look that up. I just think it's basically these 6. I might have said 7, thinking diatomic. There's 7. – 100%. Every bit of it breaks apart. If it's a strong electrolyte, every bit of it breaks apart. So we have a beaker. We're putting that in the beaker, and we got HCl. Then every bit of that breaks apart into these ions. And that's all we have is ions. We don't have anything left over of the original combination of HCl. That means everything else is considered weak. Everything else that has an H out in front that we would name an acid, because you guys know how to name acids, is weak. And it doesn't break apart 100% because the sharing of the bond between the hydrogen and the other anion for some reason is strong enough to hold together and will not break apart. So that's what we call weak acid, where they don't break apart. So HF is a weak acid. C2H3O2, if it's not one of those 6, it's considered weak. Meaning that if we would dissolve it, the light bulb would not be bright, it would be dim, because there's not enough ions being produced that creates a strong acid or a strong electrolyte. So if I would take HF like I did HCl, and I would put it in to water, this is what it will look like. Can you tell the difference? The HF stays together. It still dissolves. It's not like sugar. Sugar stays together. It doesn't break apart into ions. And that's molecular. We said there's things called non-electrolytes. When we dissolve them, like a lot of organic compounds that are not have ions in them, they don't break apart. They're not going to form ions. They do not allow electricity to be conducted. Yes, John?
Do you know why fluorine is the only halogen that isn't a strong?
I don't know. I would be speculating on why that would be. I just think that it's a strong bond between H and F compared to H and Cl. So the stronger the bond, the harder it is for it to break apart. So I would say since fluorine's such a small element, And hydrogen is small. There's a pretty good attraction between the two nuclei and electrons because they're closer. But not very many of them break apart. There's one ion here. This one here is an ion, and this one, the rest of them stay together. And that's probably not a good representation. It's probably like there's 99 HFs, and then there'll be one that would break apart into hydrogen or fluorine. So it's way less than 10%. Most of these are going to be 1 or 2% actually break apart. So what does that have to do with what I'm going to show you in neutralization reactions? The first one we're going to do is we're going to show you a strong acid, strong base reaction. So what we're going to do, first thing, we're going to go strong acid, strong base.
Why are the weak acids called weak if they're the ones that like stay together most of the time?
Yeah, you would think that they would be the strong ones, and it's relative to how many ions are formed. And also relative to electrolyte. If it's a strong electrolyte, it means it has a lot of ions to conduct electricity. Where if it's a weak electrolyte, so that's why they call it that. So we're going to take a strong acid and strong base, put them together. If you remember, the strong bases were metal hydroxides. In your notes, we said a base is a metal hydroxide. So yesterday, we took HCl, aqueous. We reacted it with NaOH, aqueous, and you remember what our product was, right? It was double displacement, meaning this Na kicks the H out and the H goes with OH. Basically, we make water and NaCl, aqueous. So this is repetitive, what I'm going to show you now, and I'm only going to show it once. I'll show it more than once, but we'll take and break apart everything that's aqueous, so it's H plus Cl minus plus Na plus OH minus. I noticed on the assignment I graded, not everybody has those in, and so I graded those, where you had to show all the reactions. Some of you are not writing charges with your elements. You need to write charges so that we can differentiate between something that is neutral and something that's an ion, and these are ions. So make sure you're doing that, okay? So that is called the complete ionic. So we have the formula equation, or formula reaction. We have the complete ionic, and then we have the net ionic. Anybody want to tell me what the net ionic would be? Yep. So
You didn't break up the NaCl.
I did.
Oh, sorry.
Well, yeah, it's supposed to be broken up.
So it would be NaCl.
But we get rid of our spectator ions with spectator ions.
HO equals H2O.
Yep. So we'd have H plus OH minus gives you H2. If they give you this on the AP test, you will be singing hallelujah because this is so easy. Strong acid, strong base.
So how do you, what is the difference between a spectator ion and
Okay, spectator ion occurs before the reaction and occurs after the reaction, and it's the same.
So when they break into ions, that means they're spectator ions?
No, not necessarily. When they're still ions on the product side.
So whichever, like you get because liquid aren't precipitates, but whatever you get as an actual compound is
Right. Right. That's why we don't break apart water, because the OH and OH come together to form a molecule of water, which is liquid, which is a new product. We didn't ever have water to begin with. Even though it's in a solution of water, we are making water within water.
So whatever's soluble is spectator ions.
Whatever's soluble on the product side are going to be the ions that you're going to cross out.
Okay, gotcha.
Yep. Now, all strong acid bases, this is what you end up with. So if I say, you know, you'll like me for this too if you know this. So if I say, okay, go ahead and write the net ionic reaction for HClO4 and KOH. And then you'll look at both and go, oh, I know that HClO4 is a strong acid, and I know I got metal hydroxide that's a strong base. Automatically you can go, oh, that's H plus OH minus gives you H2O. I'm done. Done. I don't have to go through and do the net ionic and the complete ionic. And, well, this is a net ionic, but I don't do the complete ionic. Because I know that ClO4 and OH are going to be spectator ions, and they're going to cancel out. And that's what we get for strong acids and strong bases. Pretty easy. Automatically, you just write H plus OH minus gives you H2O, and you got it. Now, here comes the weak acid. Weak acid is going to mess things up for us, because they're not going to be as easy. And this is the one that's most commonly missed on the test. So if we have a test, and we go a ways, you know, we go into next week, and then we have some sort of a test or quiz on this, students will forget, and they'll write everything like this, whether it's weak acid or a strong acid. They'll write it like this. So I need to show you a weak acid, strong base reaction. So I'm going to take a weak acid and a strong base and show the difference. So I'm going to take HF, which is a weak acid, and I'm going to react it with a strong base, which would be NaOH. You go ahead and figure out the rest of it, at least for the formula equation. You guys have that? Same? You remember when we did reactions with precipitates, if we said it was slightly soluble, we would do what with it? What would we write with it?
Say solid.
Solid. If it's moderately soluble or slightly soluble, we would write an S. Because we'd said, it's going to be some solid form. So we're going to write an S. Because it doesn't break apart 100%. Right? So this one, when we write the net ionic, this is the net ionic, or not net ionic, complete ionic, we're going to keep the HF together, and this is the common mistake students will make. They'll want to break the H and F apart. Since they see it's aqueous here, since we had everything it's aqueous, we're going to break everything it's aqueous apart. You can't do it with weak acids. Because we go back to our drawing we had earlier to show that it's not breaking apart. You can't show them broken apart if they don't break apart. 1 out of 100 is not breaking apart. So you can't show that in that next step as a net or a complete ionic. You can't show the ions on that. Yes?
Can you just like put it as a liquid for the sake of like not listening?
No, you can't, because it's not a liquid. It's actually HF is actually dispersed throughout the water. It's just in a form of molecules. So if you said it's a liquid, then that means there's nothing else present.
So that just means like a homogeneous mixture.
It's still homogeneous. It's still a mixture. It just doesn't break apart into ions. And if it doesn't break apart into ions, then we say we can still say HF aqueous. We can still say glucose when it breaks apart as aqueous, even though it's all hooked together. Plus Na plus OH minus gives you H2O plus Na plus F minus. Any questions on that? Does that make sense? So we're not breaking apart the HF.
That's your complete rate, that's the complete.
That's the complete. This is the complete ionic.
We're not breaking it apart because it is a weak.
Right. Weaks don't break apart.
So basically we have to memorize those other ones. So
You don't have to, all you have to do, Mallory, is you just have to memorize the strong acids, because everything else, if it's not a strong acid, you'll keep the acid the same way, all the way down. You keep it together all the way down. Unless it's a strong. And if it's strong, you don't even have to go through the steps, because it's this H plus OH minus gives you H2O.
How can we break? How can we broke off NaF?
Because it's sodium fluoride, and if we look at our solubility table, anything with NAs in it is soluble. So that's why that one's soluble.
Is that a rule we're gonna have to know too? Or are we-
No, I mean you can look at that solubility list to double check. So then the last one, we get rid of our spectator ions, which would be Na, right? But the F not, because it's still with HF. So then we only get rid of one spectator ion, so it becomes HF aqueous plus OH minus gives you H2O plus F minus.
So is hydrochloric acid neutral? It doesn't have a charge? Like, cause hydroxide is like minus. Does HF have a charge?
HF doesn't have a charge because it stays together.
So it's neutral.
Neutral. For the most part. There's some of them that break apart,
Yeah.
but we don't show those because they're the minority. Very much the minority.
Oh, okay.
So we won't show anything that doesn't exist very much. Okay, this will take a little bit of time, but it's the same process. You write out your 3 reactions. I've got a short assignment to have you to do. Next Wednesday we will have a quiz. What will the quiz cover? The quiz will cover information about precipitate reactions, being able to write them. You handed that assignment in. Talk about solubilities, if it's insoluble, soluble. Limited reactants. This is chapter 4, but we did in chapter 3 limiting, where you have to determine amounts that are formed based upon what's limiting it. And then the strong acid, strong base that we're doing today. So, and then we'll revisit those on Monday. Make sure you're knowing how to do those, so you do have a little bit of time. And that's what we're going to have a quiz on Wednesday. Okay? And so your assignment that I'm going to give you, there's where you have to do a couple of these setups. So, page 183. And let me look, I made this up at the beginning of last week, so I might shorten it up for you just to see.
Ow.
No?
No, it's just stabbing me.
Oh, I thought maybe you didn't want me to shorten. Okay, I won't shorten it up. I'll make it.
Stabbed me in the eyeball.
Did you get a new shirt?
I did.
It's nice.
Thank you.
Love black and white.
In gray.
Wait, why did you wear jeans today?
Friday.
It's Friday.
I thought you had to wear a Beatrice shirt, though. That's not Beatrice.
Yeah, it
Black.
It's under
It's Under Armour. I think
Oh,
Under Armour
shoot. Did
counts.
you get that from the Under Armour?
The teacher was
is. 65 and 67 on page 183. I'll shorten it up for you. 65, 67. Do you guys check your answers? Because sometimes you
No.
hand in assignments and it doesn't look like you even check your answers to see if they're even right or not.
I usually
Well,
do the homework. 'Cause you don't really
sometimes.
take it.
You ought to check your. That way you can go, I'm getting these wrong. Maybe I should ask a question on this.
But yesterday you gave us an even one, so then that really drew me in.
Right, right, they'll do that.
I did do yesterday's second time.
I did it.
You should be able to do everything. The only thing that's new is the concentration of the ions.
Yeah, I don't know how
That
to
was
do
it.
that.
There's like a 2 out in the
Did you
front.
write down the example I did?
Yes.
And did you look at